Hello friends, so today we are going to solve questions from rotational motion and these questions are from the year 2022. We are going to solve one question and this question is from the advance. So it states that a horizontal force F is applied at the center of mass of a cylindrical object of mass m and it is r perpendicular to its axis as shown in the figure. Here also I missed to paste the figure. Okay. The coefficient of friction between the object and the ground is mu. The center of mass of the object had an acceleration a. The acceleration due to gravity is g. Given the object rolls without slipping, which of the following statement is or are correct? So we are given that a horizontal force is applied at the center of mass. So we can just draw an approximate figure. So we have a horizontal force at the center of mass, okay, and perpendicular to axis. So it means the axis will be something like this into or out to the paper, and its radius is given to us as r. So this is a basic figure, and we have to check which of the options is correct. So let us suppose it is having angular acceleration alpha and a linear acceleration of a. So it is going to have two types of motion, translational as well as rotational. And we have a surface on which it is going to move, and that is without slipping. Yeah, it's without slipping. So the frictional force will be acting in the downward direction, in the backward direction, so that it is going to provide a, so let us frictional force is given as F. So we can write the equation that for pure rolling, linear acceleration which is given as a, and angular acceleration which is our alpha. So we can write the relationship between the two, that is our a is equal to alpha times r, and F we said is our frictional force, and we have two types of motion in governing this entire setup. One will be our translational motion, and based on this we can write the force F is toward the right, frictional force is toward the left, will be equal to mass into linear acceleration. Okay. And we have the second motion type of motion is our rotational motion. Rotational motion, or we can also call this a torque about center of mass. Torque about center of mass. And the frictional force is the only force which is going to provide the torque, because this force, applied force F, is through the center of mass. Okay. Therefore, we can write that the torque, that is our tau, will be frictional force multiplied by R. And this, there will be our, or we can say the moment of inertia, which is our I. This will be about center of mass and x is perpendicular to the plane. Okay. So we can say this will be about center of mass. And we can write that our tau will be equal to I multiplied by alpha, and we can also say that our tau is our Fr, so we can say our Fr is equal to I alpha, and alpha we can calculate from here. Alpha is equal to A upon R. So we substitute it, we get this as our I into A upon R. So this gives us that the frictional force F will be equal to IA divided by R square. And we have already the equation that, let us call this as equation number 1. So we can say, using equation 1, we can write our F minus IA upon R square will be equal to MA, and we can just make a minor adjustment which gives us that our F is equal to MA plus IA upon R square. And from here we can take A as common, so which gives us that our A will be equal to F upon M plus I upon R square. So this is a general expression for our linear acceleration. And so in this case we have to remember that our, more or less, this entire motion will be governed by the friction. Okay, so we can write that for no slipping, our frictional force should be less than equal to mu times n. N is normal, or we can say this will be equal to mu mg. And therefore we can also write that our IA upon R square should be less than equal to mu times mg. And if we want our A should be maximum, so we can say that our maximum A is, for F is equal to mu mg, or we can also say it as a verge of slipping. Verge of slipping. Okay, so these are the some things which are dependent upon the our friction. Now one by one we are going to check our options, because we have a solid cylinder, we have thin wall cylinder, and this is also with respect to cylinder, and this is only for the frictional force. Okay, so let us consider a solid cylinder, then we can move forward. So we have two cases. We have case 1, which is for solid cylinder. And for solid cylinder, we know that our moment of inertia of I is equal to 1 by 2 mr square. Therefore, our acceleration A will be equal to F upon m plus this becomes half mr square upon r square. Here r square and r square cancels out. So this comes 1 by 2. 1 by 2 will be equal to 3 by 2. And this will be equal to our 3m upon, and this is our 2f. And our frictional force F will be equal to our half mr square multiplied by A and divided by r square. Here this r square and r square cancels out. So this comes as our half m A, and in terms of the force we can write this as a half m multiplied by 2f divided by 3m. Here m and f 2 and 2 goes away, so this comes as our f by 3. And for maximum, A, that is a linear acceleration, we already know that F should be equal to mu mg. We know that F is equal to mu times mg. We substitute, we get this as our 1 by 2 ma maximum will be equal to mu mg, and here m and m cancels out, so we get that our A max will be equal to 2 mu g. Therefore, we are going to find out our maximum force. So we can say that corresponding maximum force, which is our F max, will be equal to our A max, A times max, A max multiplied by m plus F. So we substitute the value, we get our force maximum, which will be equal to our m 2 mu g plus mu m g. This gives us 3 mu m g. And from here we can just draw a slight conclusion that if the applied force is greater than our maximum force, then under this condition slipping is going to take place. Slipping occurs. And we can also say that our acceleration will be equal to A max, greater than A max. Okay, but the friction now will be the kinetic in nature. Now the second case is our thin hollowed cylinder. Is our, which we called it as a thin walled cylinder. Thin walled hollow cylinder. And for that, our I, moment of inertia, is equal to our mr square. Therefore, we can say our acceleration A will be equal to F upon m plus mr square upon r square. R square and r square goes away. So we get this will be equal to F upon 2 times m. Similarly, frictional force F will be equal to mr square multiplied by A divided by r square. R square and r square goes away, and this comes into mass into acceleration, and our acceleration is F upon 2m. So this comes as F multiplied by F upon 2m. M and m cancels out, so this comes as F upon 2. And for maximum acceleration, that is our F should be equal to mu m g. You can say m into A max will be equal to mu m g. Here mass and mass cancel out, so A max will be equal to mu g. And corresponding maximum force which we called as our F max will be equal to m times A max plus F. Now we simply substitute the values. We get this our F max will be equal to our m mu g plus mu m g, which comes as 2 mu mg. Now let's evaluate the corresponding options. So first option, it states that the magnitude of the frictional force on the object due to ground is always mu mg. Okay, so we found out that our the magnitude of frictional force on the object due to ground is always mu mg. So let us option A and option A gives that frictional force on the object due to ground is always mu mg. And one second. The magnitude of frictional force on the object due to ground is always mu mg. Yes. So for this, we can say that we calculated the formula also for our F, where it is, 1 second, yes. So frictional force F is our I multiplied by A and divided by R square. So we know that our F for pure rolling is, we calculated it is IA upon R square. And we also know that our A is dependent upon the force. Okay. And we also calculated that this F will be equal to over F by 2 and this F will be equal to F by 3. Okay. So both for hollow as well as our solid cylinder, we calculated that our F is equal to, frictional force is equal to F by 3 and this F is also equal to F by 2. So it means that our frictional force is not always mu mg. Okay, it is going to change depending upon our what kind of object we are rolling. So the option A is incorrect. Option B states that for the same F, the value of A does not depend on whether cylinder is solid or hollow. For the same value of F, the acceleration does not depend upon the cylinder is hollow or this. And we calculated our acceleration for our hollow. We found out that our acceleration is F upon, 1 second, yeah, acceleration is upon 2F upon 3m, and for hollow we calculate our acceleration is equal to F upon 2m. So we have our option B. So this option is incorrect. Option A is incorrect. Now we come to the option B, which talks about the acceleration, and we found out that our acceleration is equal to 2F upon 3m, and we found for the second part, case 2, our acceleration is equal to F upon 2m. Okay. And obviously this is for same F, so acceleration is also different. So this option is also incorrect. Now we come to the option C, and option C, it states that for thin wall cylinder, acceleration is equal to F upon 2. Okay, and obviously we just calculated, so this option is correct. Option B is incorrect. And for solid cylinder, the maximum possible value of A is 2 mu g, which also we calculated. Okay, so this option is also correct. So option C and D are correct. So option C is correct, and we have option D, which is also correct. So this completes the question. Thank you.